take a look at digital signals. The digital pins, as I mentioned before, are placed on top of the education shield and the 101 board. Digital signals can be either on or off. So just like in the blink example, we're putting an LED on and off over and over again. You've probably heard that computers generally communicate through ones and zeros, and this is the same principle. In electronics, we can also simulate this or communicate this way using max voltage and minimum voltage. And as soon as we know the difference, we can set something to on or off. Now, these two states can be used for both input and output. So if you connect a button, for instance, you can read whether it's on or off. And in turn, you can of course use it as output to put an LED on or off, just like in the blink example. We're going to take a closer look at LEDs. There are different kinds of LEDs, so they come in various shapes and sizes, and they can actually be quite beautiful. Now here are some 3mm ones, here's a 5mm LEDs, and here we have 10mm ones in different colors. These are all standard ones, and if you take a closer look at one of these, you'll see that it has one long leg and one short leg. Now, it's important that you remember to always connect the long leg to power and the short leg to ground. This is what we refer to as a component's polarity. There are components that don't have polarity, and you can easily see that because the pin legs are actually the same length. So as I mentioned, there are different types of LEDs. We have onboard surface-mounted LEDs, like the LED that we just blinked now on the board. There are bicolor ones and tricolor ones that allow you to mix them into different colors. And there are infrared LEDs and high flux LEDs that are very good at saving power, for instance. Before we start to connect our LED, we need to make sure we have some fundamental understanding of circuitry and electronics. If we were to put this LED and connect it directly to voltage, it would burn out. So how do we avoid this? Well, we simply use a component called a resistor. Resistors are made up of both resistive and conductive materials. And with the help of resistors, we can change the total voltage or current in a circuit. So in this specific example, we need one 220 ohms resistor. It looks like this. If you want to calculate the resistance of your circuit, you can simply use Ohm's law. So in the formula, the I represents current, the V represents voltage, and R resistance. So if you, for instance, want to know what current you have in your circuit, you just need to take your voltage and divide it by the resistance. If you want to know any of these three, you can easily calculate it based on the other two. Different resistors have different resistor values, and we can easily calculate what value our resistor has based on the colored stripes on its body. So let's take this resistor as an example. If we look at this resistor, we see that it has one brown stripe, one black stripe, and one orange stripe. And then it has a golden stripe on the far right edge. Now, using the table in the illustration to the left, we can simply calculate the resistor value. So if we take the color brown, for instance, it represents number 1, so then we have number 1. And if we look at the second stripe, we have the color black, so then we have a 0. And the third stripe represents our multiplier, and this value is going to determine how many times we need to take 10 times 10. So basically we have 1, 0 times the third value, and to count the third value we just check what value it represents, and orange represents 3, so then we take 10 times 10, which is 100, and then we take 100 times 10 again, and then we are up in 1000. So now we have 10 times 1000, which makes 10,000. And 10,000 ohms is basically also the same as 10 kilo ohms. The breadboard on top of your education shield is what we use for prototyping. Now if we take a look inside the breadboard, we'll find different terminal strips that interconnects these holes. And these are connected in a certain direction, so it's important that you remember what direction this is. In this case, it's this direction that I'm showing here. Now, in the middle of the breadboard, you'll find a gap, and this breaks the connection between the two sides. So this is very useful to place your components, because then you can assure that the legs are not going to be connected into the same stripe. There are different types of breadboards. This is a mini breadboard that we're using here, but there are also these big ones. Now in this case, the terminal strips are going this direction here, and the opposite direction on the edge. This is very useful when you have a lot of components that you want to plug into power and ground, for instance. But in the CTC program, we only need to use this mini breadboard for everything. So let's use the breadboard to actually connect our LED using our 220 ohm resistor. So for this, we will need 2 jumper wires, 1 LED of course, and 1 resistor. We make sure we know which one of the legs is the long one, and I bend it slightly like this, so it can still be even when I put it down in the breadboard. So I'm going to connect it exactly as in the illustration that you're looking at. Then we take the resistor and we connect it to the long leg. And then you need to make sure that the resistor is going to the next strip, so it's not in the same row, because then it's not going to go through the resistor. Great. Then we use our red cable in this case, connected to our pin, and our pin is still pin number 13. Then we connect the other short leg to ground. Okay, great. So now that we have connected our LED, we simply need to upload the code. But maybe you also remember that we actually uploaded this code before, so we can just plug it into the computer. And our sketch is going to start running in a couple of seconds. There we go. So now, as you see, we have this LED that we plugged into pin number 13 that's blinking. And we also have the surface mounted LED on the education shield blinking at the same time. Let's take a look at the code in this example. So, starting out, we use the function pinMode to assign our pin as an output, and this is pin number 13. Then in the loop function, which goes over and over and over again, we use the function digitalWrite, and we assign pin 13 and set it to high. We use a delay of 1000 milliseconds, which is 1 second. And then we use digitalWrite once again, but this time we set the pin to low, and which means we turn it off, and then we have a delay of 1 second again. So just for fun, let's change this value and see what happens. So now I lowered it to 100. We compile the code, and we upload the code to the board. And now, as you can see, it's blinking a lot faster because we lowered the delay value. So what happens in this loop is that it turns this LED on and off with our specified delay. For the sake of repetition, let's look at the code we're using. So we're using a function called pinMode, and we assign the digital pin we have chosen. In this case, it's pin number 13. We declare it as an output because our LED is an output. And we use the function digitalWrite, and we tell what pin we're talking about, and then we set it to either high or low. Then we also use a delay and with an in parameter of milliseconds. So one LED can be kind of fun, but what's even more fun is 5 LEDs, for instance. So that's what we're going to try next. We're going to demonstrate the VooMeter example that you can find in the education shield, but first we need to connect 4 more LEDs onto this breadboard. So once you have your 5 LEDs plugged in, you can just upload the code through File, Examples, Education Shield, and Help and VooMeter. It's always good practice to compile the code. So let's do that before we upload. And then we upload the code to the board. And now, as you can see, all the LEDs light up, and then they start to animate in a pre-programmed pattern. So let's take a look at the code. What we do first is that we declare an object of the class VooMeter and call it me. Then we create an array of integers where we can place our pins, and in this case we're using pin numbers 2, 3, 4, 5, and 7. These are the ones that we have connected here. Then we declare how many pins we have in total, and in this case it's 5 because we have 5 LEDs. And then we configure them using our pin count. We say, hey, we have 5 pins, and then we define exactly which pins they are using our array. Then we initialize the component, and then we go over to the loop, which is where the actual action happens. So we call the function fill, and we send a 5 with it to tell it that we want 5 LEDs to light up at the same time. Then we have a 3-second delay, and then we call the function clear, which means we turn all the LEDs off. and then we add another delay of 1 second. And then we have the function which allows us to turn on a specific pin. In this case, we're saying we want the pin in the array number 2, and that is the pin number 3. And then we have the delay, and we turn that same pin off. Then we use a function called scroll right, and what that function does is that it scrolls from left to right. And we have scroll left, which does the opposite. And then we have blink, where you can specify a certain pin to blink. So basically, just for repetition, these are the functions we were using. The ones we didn't mention were blink all, and for that function you can set the speed and tell it to blink a certain amount of times. Then we have the function fill from, where you can start at a certain index in your array and stop at another index.